In the last 5 videos, I've been explaining the theory behind the AI-Driven Development Lifecycle, or AI-DLC. The methodology, the phases, the taxi teams, and the modular specification architecture. But now, it's time to show you how it really works, real-time, on a non-trivial system. Look, adoption is table stakes these days. Adaptation is the real engineering challenge. You watch tutorials and you read frameworks, but you still wonder, what does a real engineering session look like when you treat the AI agent as a development partner rather than a magic copy-paste machine? Where do agentic workflows go completely off the rails? And where do you, the human agent, apply architectural tastes to course correct mid-execution? And today, you'll see that every single step. Let's get started. Hi, I'm Derick Chen. I lead the AWS AI-Driven Development Lifecycle program across 7 APJ countries, which I built and scaled from the ground up. Working directly with customers across industries, I've helped teams achieve 5 to 20 times faster development velocity by reimagining the software development lifecycle. I share these results on the AWS reInvent stage. And in this series, I'll break down exactly how they were achieved, the trade-offs, and how you can start applying them in your very own organization. Here's our intent. We want to build the core transaction-heavy application layer of a complex travel booking application. To pull this off effectively without creating catastrophic technical debt, we must first define our roles clearly. In our AI DLC taxi team setup, I will act as both the product behavior lead, mapping the business rules, and the software system lead, enforcing the architectural boundaries. And for our execution partner, we have Claude Code CLI operating natively inside our terminal interface. So the first step is to clone, bootstrap, and wire up the Claude Code with AI DLC. I've downloaded the latest open source AI DLC rules bundle from the AWS Labs GitHub repo into my workspace. Let's take a look at the workspace right now. We have key rules and compartmentalized prompts in the rule details folder, and we leverage CLAUDE.md as the orchestrator. Content architecture is basically system architecture today. This layout is our core defense mechanism against context window pollution. The combination of CLAUDE.md and our structural tracking state isolates the execution path. As you can see, the phases and the steps, the plan, execute, validate loop of AI DLC are all abstracted into this harness. We copy the core workflow rule directly into the project root as CLAUDE.md. Then, we spin out the project details directory and port over the deep execution context files. When I initialize Claude Code CLI, the very first thing it does is to read Claude Code.md. And there are instructions for it to parse the AI DLC rule details folder. It instantly inherits our workflows, prompts, and our architectural constraints before even writing a single byte of the application logic. And to get started, we can simply ask Claude Code to start AI DLC. We begin the Inception phase by declaring our intent to Claude Code. This is a guided process. As you can see, Claude Code automatically starts the plan, execute, validate action loop for each step in the Inception phase. It generates clarification questions together with a plan document to formalize the plan for the execution. Now, a quick warning. The AI DLC design phase is intentionally heavy by default. Because this workflow and the methodology is built for high complexity distributed systems. It expects extreme precision. But to save time and to keep momentum high, it is completely fine to leverage Claude Code to fill in some of the structural blanks during the initial planning loops after you have defined the intent and the objectives. I've received many positive feedback from PMs on the clarification process. It helps to uncover blind spots and edge cases that significantly reduce requirement changes mid-iteration, or what we call BOLT in AI DLC. This is where the human technical calibration is required. We don't blindly accept the structure or the proposed execution content. We adapt this to our business context in a mob ceremony, combining the experience and knowledge of our human team. So as a software system lead I manually step into the document and adjust the constraints. For today's demo, I won't be including an authentication service, so I will course correct this in the validation phase of Claude Code's requirement generation. Now, look inside the AI-DLC-state.md and Audit.md documents. Claude Code has serialized our current progress inside the AI-DLC state, and with more details with decisions and approvals in the audit file. This is essentially the cross-session memory function for AI-DLC. If my terminal crashes or if I need to step away from my desk for 2 days, this local file allows any engineer to pick up right where we left off. But let's see how this actually works and how I can resume the previous build with a new Claude Code session. Another interesting discussion point is that the AI execution within each step can take some time as the context becomes increasingly complex. Now, what should a human team be doing? You could take a break while the AI is hard at work, but you must be intentional with the reviews at each approval stage. You have to be the gatekeepers of quality. Any inaccuracies or hallucinations will result in massive frustration downstream and cause way more tokens to fix. After we have clarified the product details, in the final step of the Inception phase, Claude Code breaks down the entire specification into modular units of work with clear dependency maps. Once a feature is cleanly decoupled into these services or independent units of work inside the state tracking architecture, multiple engineering teams can then step into the codebase and build out the distinct units in parallel without causing context collision or merge debt. But for today's demo, let's just focus on one unit and let's push straight into the construction phase. Now we're transitioning from the Inception phase, where we define the what of the system. And now we want to focus on the how in the construction phase. And we start with the technical design of the selected unit, including the functional and non-functional design, though I prefer to view them as behavior and performance design. This is where we may need to perform a careful review of the design specs as a team, to combine our expertise as we now define the structure of the system which we're building. Any mistakes here has a high cost of future change. And once we're happy, we can check in the design docs and approve the source code implementation plan. And at this moment is the best time to execute context compaction. We explicitly tell the agent to stop looking at wide, high-level business scope and to lock its vision into the narrow, hyper-focused unit boundary. In the source code generation phase, once we have clearly defined the upstream constraints and designs, we now have a clear scaffolding for rapid and highly accurate code generation with Claude Code. And in the construction phase, there are two common questions that get all the time. The first FAQ is, how do we scale front-end development? If you let an AI agent build UI components from scratch on a page-by-page basis, it will completely fracture your user experience, duplicate style constraints, and build massive technical debt within days. The architectural rule for AI-DLC front-end execution is simple. You must establish a centralized UI component library first that is closed for modification and open to extension. Now you can design your pages on Figma or using MCPs to port it over into your workspace. And when you instruct the agents to build new pages, you limit its scope to only importing and composing those pre-established primitives, rather than writing raw layout components from scratch. This guarantees consistency and keeps design constraints locked in. And FAQ number 2, how do we handle security compliance? You cannot expect an AI model to magically guess your corporate security postures and compliance needs. But you use a similar tactic as we did for front-end. Build a centralized security wrapper libraries and declare global compliance requirements as additional skills for the AI agents. This also applies to architectural best practices. This way, best practices and guardrails are invisibly injected into the workflow with minimal friction for the human engineers. What you practically do is to modify these rule details files to add your own context and constraints. Now coming back to our demo, at this point, feel free to dive deeper into the critical implementations to further validate the output. Otherwise, we'll move on to the next step to build and test the implementation locally. Test generation is already an integral part of the workflow, and in my opinion, it is more important to review the tests than the source code itself right now. But we still should verify the correctness of the unit by spinning it up locally. And depending on the complexity of the build, this stage may vary from running a local container and firing off the unit tests to deploying it into a dev environment and verifying the integrations with other couple units. And in today's demo, I will deliberately omit the final cloud infrastructure deployment and operations phase. The reality is that the operational pipelines, CI/CD automation systems, and security clearance barriers vary way too much from company to company. Attempting to show you a generic one-click infrastructure deployment template today isn't particularly helpful. Your team's specific target deployment infrastructure must be explicitly declared within the system specifications and deeply integrated into your local AI-DLC operational workflow and configurations. The default rules in the AI-DLC workflow are meant to be extended and adapted into your own projects and platforms. And let's be completely candid as we wrap up this demo. If you think transitioning to the AI-driven development lifecycle means typing a few vague prompts and waiting for Claude Code to do the best, and hitting accept for the rest of the day, you are completely missing the mark. AI-DLC is an intense exercise in continuous human technical taste and calibration. Let's look at the actual friction points we hit during the build today. And first, the over-engineering impulse. When left completely unconstrained, Claude Code initially attempted to introduce a massive, distributed, event-driven microservice system for what was fundamentally a synchronous transaction engine. I only wanted to implement this engine as a demo prototype, so I had to step in during the design phase to violently pull back the scope. The second common problem is the Runaway codebase. If you don't intentionally spend time to review and digest the generated design documents and key source code implementations, we will lose control of the codebase. I have seen this happening with teams on the ground. This severely limits the continuous adaptability of the project for future enhancements. And let's run the final metrics of this build. From just the raw business ambitions, or what we call the intent, to a fully implemented, test-covered travel booking engine took us exactly 3 hours. But of course, for today's demo, I've accelerated certain product features and implementations to showcase the key takeaways of AI-DLC. Remember, AI-DLC is completely tool and model agnostic. It doesn't matter if you're running Claude Code today, Cursor tomorrow, or advanced multi-agent reasoning models next year. The underlying engineering architecture remains completely identical. Treat the open source repo as a foundational starter kit. Take it, clone it, and actively wrap your own corporate specifications, custom testing tools, and opinionated architectural best practices around it. Just like any agent tools or frameworks, adoption is easy, but to make it really work, you need to spend time adapting that to your own environment and context. And a final word of warning as you scale. Utilizing multi-agent orchestrations or background sub-agents can massively accelerate your loop completion speed. But it will cause your token consumption costs to skyrocket aggressively. So calibrate your workflows accordingly. So start slow, experiment with the default workflows, and see where you can make it more efficient in your team's context and business environment, and then to make the system as performant as possible. Remember, slow is smooth and smooth is fast. As we move more towards an AI-driven and AI-managed software development practices, we must act more like a conductor for an agentic orchestra. I hope you find the demo today useful. My name is Derick Chen, and this is Build with DC.